Chalo. Now no more talk. Aa So we were talking about the first 20 elements. Okay, what all did we discuss the other day? We had a fair bit of idea of atoms. We had a fair bit of idea of subatomic particles. We had an idea of what is nucleons. Nucleons are the residents of the nucleus, comprises of protons and neutrons. Protons being electronically charged positive, electrons being negatively charged, and neutrons being electrically neutral. The mass of a proton and the mass of a neutron are same. Charge of an electron and charge of a proton are same, right? Then we also understood that there are some, we have to understand today concepts of what are free electrons, what are bound electrons, okay? And then we said that we need to understand the periodic table. Now tell me how many of you have a periodic table in front of you, because that has to happen with them also. I said that you should have a periodic table. So golden words are said once. If you don't have from tomorrow also, nothing goes from my side. If you have a periodic table, it's very good, okay? So this chapter, there was a chapter earlier before COVID called Periodic Classification of Elements in grade 10, which was there as a board chapter. Then it was taken off. This year it has been reintroduced for internal assessment purpose and projects. Questions will not come in what you call main grade 10 exam, but it is for internal assessment. And I'll tell you why I'm teaching this. Earlier, periodic table used to be there as a part of grade 10. And then when you go to grade 11, you have periodic table as a chapter. Now, the batches who have passed before you, they have not learned anything about periodic table. Nothing. A CBSE child has not learned anything. And when the child goes to grade 11, they will start learning periodic variation, periodic properties and all. Are you understanding? So, यहाँ काटा है, वहाँ नहीं काटा है. So, यहाँ पे सीखते हैं. So, as grade 9 students, our job is to be familiar with the first 20. The first 20 elements, okay? The first 20 elements, and let us now understand the periodic table today a little bit more in depth. So as we are in grade, what do you call, as we are in grade 9, our job will be not using the entire periodic table. Okay, the periodic table comprises of periods and columns. Columns are known as groups and periods are rows. So we would be dealing with group 1, and this is say group 2, right? Group 1, group 2. After that comes group 3, right? 4, 5, 6, 7, 8, 9, 10. So our next interest would be straight away at group 13. So we would be at group 13, children. So from 3 to 12 is not our headache right now in terms of group. So this is group 13. After that, I would have group 14, right? Group 14. 15, right, 16 and 17 and 18, okay? So, sorry. So, group 17 and 18, understood? So, let's start. First, we have period 1. This is my period 1. Periods are the horizontal row, period 1, right? My first element comes here, hydrogen, and so this is G how much? G13, G14, G15, G16, G17, G18. G18 are the noble gases, okay? These will be known as my inert gases. Inert gases. This is G18, and G17s are known as halogens. Let's get some names today. Halogens. Group 1 is known as alkali metals. Alkali metals. And group 2 is known as alkali earth metals. These are all old age names. Means these are metals which will be alkalis. What is alkali and all we'll understand. These are alkalis which are found in the earth's crust. So they are known as alkali earth metals, right? So janna chahiye, group 1 general knowledge is known as alkali metals, alkali earth metals. And now the periodic table classifies elements in such a manner that we have the metals. What are the elements? The elements are of 3 types: metal, non-metal and metalloid. Metalloid is someone who can behave in between metal and non-metal. Like carbon is a metalloid, okay? So the left side is all on metals. Group 1, which we are studying, will be metal. Group 2 will be metal. Group 13 will also be metal. However, there will be some interesting observations. If you see, hydrogen is a gas. Hydrogen's position till date is not clear. So hydrogen has been assigned, hydrogen is not counted as a group 1 element because rest of the group 1 elements are all metals. But if you look at these metals, these are not metals which will be hard, which will have sonorous sound. Metals have a sonorous sound. This will not be metals which will be like, hard, sonorous, then luster. They won't have any shine like them, because these metals are like sodium, potassium, calcium. You can't make a rod of calcium and hit her on her leg. There will be no fracture. But in between, whatever you have left, the D block, those are the real metals like we know. The tungsten, the vanadium, the chromium, the copper, the cobalt, the manganese. Make a rod, hit her, fracture is ensured. Understood? And then we go to group 13. 13 is also metal. These we will see why they are metals, okay? Then 14 onwards will be metalloid. And slowly you will see all non-metals on this side. Non-metals can be either gases or they can be solids also, but they are non-metals. In the entire periodic table, there is only one liquid which is assigned to non-metal and one liquid to the metal side. The liquid which is this, you can write. The only liquid non-metal is bromine or bromine, whatever you say. The only liquid non-metal is bromine, B-R-O-M-I-N-E, or bromine, whatever you say. Its symbol is Br. The only liquid non-metal. The only liquid metal is mercury. The only liquid metal is mercury. So what did we understand? Out of 114 or so elements, we have got only 2 liquids. See, children, try to understand. Metal, non-metal is one categorization. Solid, liquid, gas is a different categorization. Understood? Metal means it will always be solid. Non-metal means it can be solid, it can be liquid, or it can be a gas also. In metals, there is only one exception, that is mercury. Mercury at room temperature always is a liquid. If you freeze it further, it becomes solid. But mercury is a metal. Okay? And in case of bromine, bromine is usually a gas. But in room temperature, it can come as a liquid. So bromine is the only non-metal which will behave as a liquid. Understood? Rest all elements in the periodic table are either solids or gases. Liquid or koi nahi hai. There is no one liquid. All are either solids or gases. AG, not short form, beta. It is known as symbol. So we have got hydrogen, okay, hydrogen, and this is inert gas. So here comes helium. Hydrogen's atomic number is 1. Helium's atomic number is 2. Clear? Next starts our next row. Sorry, our next period. So this is period number 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so you can name them. This would be 3, this would be 4, this would be 5, 6, 7, 8, 9, 10. Slowly, as you keep on learning, you will learn so many techniques after which this will become very easy. You need not memorize at all. Okay, then comes my period 3. So the ones who have a periodic table today with you, you will see from period 3, you will see the transition elements will start actually. D block starts. Okay, from period 3, the D block will, the 3 will drop. For 4, the period transition will start because there is a D orbital. All those we will learn later. Okay, lithium. Now, then comes our period 3. Then comes period 3. We have sodium. Okay, we have magnesium. We have aluminium. Below carbon will be silicon, phosphorus, sulfur, fluorine, chlorine, neon, argon. Okay, so 10, this is 11, this is 12, 13, 14, 15, 16, 17, 18. Fine, and we are supposed to know only up to 20. So this is my period 4. I have potassium here and I have calcium out here. So this is my 19th element and this is my 20. Just for knowledge, you should know your what you call helium, neon, argon, krypton, xenon, and then you have radon. Sodium, potassium, helinaki, ruby, say friendship. So you should know this also. Cesium, francium. That's all. Okay. Now, so let's take an atom. Let's take an atom of, say, oxygen. Let's take an atom of oxygen represented by O. The atomic number is 8. Right? Represented by O, the atomic number is 8. In this 8, what do we get to know? 8 is the number of protons, which is represented by A, not A, Z. Sorry. 8 is the number of protons, and that is represented by, and this is known as my atomic number. Is this clear? What does this mean? It means one atom of oxygen has got 8 protons with it. Okay. Now let's say the oxygen atom is neutral. Let's say the oxygen atom is neutral. If the oxygen atom is neutral, it should have 8 protons and it should also have 8 electrons. Yes or no? So there will be plus 8 charges on this side, negative 8 charges, which makes it. Our job today, and protons are always associated with the nucleus, because they are also, but these are in what we call as orbits. Today what we will learn is something called electronic configuration. Electronic configuration. Electronic configuration means how are the electrons arranged in an atom or distributed in the orbits of an atom. Okay? How the electrons are distributed. So just write electronic configuration. It means how the electrons are distributed in the orbits of an atom. Like there are how many electrons now for oxygen has how many? 8 electrons. How are these 8 electrons distributed in an atom of oxygen? That is what we are going to learn. So our main topic today is electronic configuration, and we will be learning the electronic configuration of the first 20 elements. Electronic configuration, you tell me one. What is the flat configuration? What do you mean by the flat configuration? How are the rooms arranged? Electronic configuration is how are the electrons arranged in various orbits of an atom. Okay, na? In various orbits of an atom. Now this thing was given by the scientist named Niels Bohr. Bohr's electronic configuration. Bohr's son, both are Nobel laureate. Niels Bohr, Age Bohr, both. And their Bhatija is also a laureate, Nobel laureate. So Bohr gave what is known as Bohr, the electronic configuration. So we'll study today what is electronic configuration. Chalo. Okay. So, and believe me, whatever we are learning now, everything we are learning is wrong. That you will learn again in grade 11, because unless and until you learn the wrong, because this is something science which is advanced. Whatever you're learning now, nothing happens according to this. Things happen in a much different way. So this can answer only up to first 20 odd. After this whatever way we learn now, that will not work. But this will answer many of our things. Okay. So let's understand the electronic configuration. We will read this all as a part of our syllabus, but if you have this primary knowledge, it will help you understanding chemistry much better. Electronic configuration, and this was given by Niels Bohr. Okay, Niels Bohr. So let's understand. So we have orbits, and the orbits have got some names which are like K, L, M, N, O. K, L, M, N, O. These are the orbits. Orbits are also known as energy levels. Okay, what do you understand by energy levels? These are typically like class 6, class 7, class 8, class 9, class 10. Class 6 has got a syllabus quite different from class 7, quite different from class 8. Understood? Every of this orbit has got an energy level. That means when you are an inhabitant of that particular orbit, you are supposed to have that energy associated with you. You can jump out from an orbit, or you can jump out and go to higher orbits. You can jump out and come into an inner orbits also. In both the cases, you will either lose energy or gain energy, but that amount is very fixed. There is nothing called 6.5 class. So there is nothing called K.2. If you jump, you can jump only from K to L. If you jump back, you can come L to K. So that is higher concept. Let's understand how these fillings go on. And these are given a value of n. There is an n value. The n value, now this n is not the nth term n. N value for K is 1, 2, 3, 4, 5. N value for K is 1, 2, 3, 4, 5. Okay? Understood? Now then we will see a law. How does the electrons get filled up? Now when the electrons start getting filling up, you imagine you are the receptionist in a multi-star hotel and a big school contingent has come and you have to allocate rooms. How will you allocate rooms? Generally the idea is always let one floor be filled up because there will be some general customers also. Then let another floor be filled up. Then let another floor be filled up. Then suddenly you will get some special request. I don't want to be beside his room. These things also comes. Hotel has to take care of all these things. So we have to do that filling process. So electrons are filled up using the formula 2n square. What does 2n square mean? 2n square means 2n square will actually tell you the maximum number of electrons that can be accommodated in an orbit or energy level. Many people will call them as shells also. Shells bhi sunoge aap. When you go to grade 11, these orbits and all die. It is something called orbital. There's nothing called an orbit because the electron is not a particle, first of all. That's quantum mechanics. The electron is actually a wave. 2n square. Understood? Right. So if I apply the law of 2n square, all right, if I apply the law of 2n square, the maximum electrons that K can have is only 2. This can have 2 square is 4, 4 into 2, 8 electrons, 3 square is 9, 9 into 8 is 18, then 4 square is 16, 16 2 is 32, and then so on. So on. इतना में आएगा नहीं, आपको जरूरत नहीं पड़ेगा. At your grade 9 you will not need it. Have you understood? Right. So the first law is, these are steps. You can write down slowly. Electrons fill the orbit in accordance to the rule 2n square. But there are some conditions to it. You cannot fill up another orbit till the previous orbit has been completely filled. Right? So this is one law. That is, new orbits are occupied after the previous orbits are completely, here also there will be exception. You have to remember all, completely filled. If you don't fill up level 1, you will not open the rooms of level 2. As simple as that. Now next, the next one. Now we have to understand another term here, which is known as valence orbit. Valence orbit, or they may say the word valence shell. Okay, valence orbit or valence shell. The last shell for an atom will always be known as its valence shell, and this is something most important. Yahi pe sab magic hoga. The last shell, an atom will have various orbits, right? The last shell will be known as the valence shell. Understood? Okay. Now, what all did you learn so far? You learned that the second shell can have how many? 8 electrons. The third shell can have 18 electrons. Mind you, based on all these things, there is a catch that the valence shell, this was our point number, this was point number 1, this is point number 2. Point number 3, the valence shell can accommodate max 8 electrons only. Understand? Though this shell can take 18 electrons, if this is the last shell, then you can't fill 18 in it. How much can you fill it? Only 8, not more than that. Understood? Only 8 electrons. Valence shell, if this becomes a valence shell. Are bhai, these are the various, it's like we have got twin bed capacity in every room. But the last room which is filled up, if it is the last room, we can't make it a twin room, we have to make it a single room. That is the rule. Though there are 2 beds, there can be only 1 person. Understood? So though there are 18 beds, only 8 beds will be allowed out here. If you are the valence, if he is the valence shell, he will also allow only 8. Okay? बहुत कुछ सीखा, लेकिन आपने क्या क्या सीखा? You learned the first thing, which is what is electronic configuration, how are electrons configured in an atom. You learned about that electrons are residing in various orbits which are KLMN. Oh, not required at KLMN. KLMN each has got an n number count. This n later in grade 11 you learn this is principal quantum number. This is 1, 2, 3, 4. Electrons are filled up using the rule 2n square. 2n square tells me how many maximum electrons can I accommodate, with the condition that the valence shell can always have only 8 electrons. Okay? Then only 8 electrons. Are we fine? Shall we start some filling now? Okay? With this law concept, let's start filling. Okay? Let's start some filling. Okay. So just make space. Once you understand this, your life will become jingalala. Ajo. This is atomic number, better known as your Z, and can be your serial number also. This is my element column. Understood? Then these are my shells, which are K, L, M, N. O nahi chahiye aapko. 20 tak O nahi aayega. Shall we start? So I'm changing my ink color, going with blue. My first element is atomic number 1, hydrogen. And these are all neutral atoms. Neutral atoms, just like periodic table. Shadi.com wala ladki. Hydrogen has got how many protons? Atomic number 1 means 1 proton. So it has 1 electron also. Now we have to, hydrogen has come to the hotel. I have a booking tonight. May I have my booking? Your ID, please. So they look at your ID. That's your key. So you have to give a key to hydrogen. Which room will you allot? K. 2n square. K can take how many? K can take maximum of, and here I am writing the max counts. Okay. K can take max of 2. Here we have max of how many? 8. Here we have max of 18. Here we have max of 32. Always remember 2, 8, 18, 32. That's how it goes. Okay. So hydrogen, so my element atomic number is 1, and he has come to check in. This is hydrogen. So I allocate 2. Finished? Not 2, 1. Hydrogen has got 1 electron. Next comes my friend helium is also coming. So helium has come now. Helium. And helium has got 2 electrons. So I can allocate both the electrons in K itself for helium. Are you understanding? The K of hydrogen is separate, the K of helium is separate. So if you are getting a little bit confused, it's something like this. The hydrogen atom looks like this, children. A hydrogen nucleus, which has got 1 proton, and this is the orbit, and this is the K, and in K it has 1 electron. This is how hydrogen looks like. Hydrogen is very interesting. Hydrogen does not have any neutron. Hydrogen does not have any neutron. That also we will see later. There are different forms of hydrogen, but the hydrogen that you are aware with does not have any neutron. This is called prosium. This atom is called prosium. We'll see later. And if you want to see how helium looks like, helium is this. Helium has got 2 protons and then the same K, but 2 electrons are orbiting. This is just for your understanding. Okay? I'm wiping it off. Yes, sir. Then we are nothing bothered about group now, beta. Yeah, helium is in group 18. Helium is an inert gas. And after some time, you will not ask that question. You will yourself get the answer. Helium is in group 18. Helium is in group 18. वो देखो, see. Helium is in group 18. There. Helium is inert gas. Helium, neon, argon, krypton, xenon, and radon. Okay. Helium, neon, krypton, argon, xenon, radon. Shall we go ahead? Okay. Fine. My next element is, so my period 1 is over. This is actually period 1. If you look into your periodic table, period 1 is over. Period 1, orbit occupied is only 1. This is a logic. Now we are going to period 2. So in period 2, because the element that starts period 2 is lithium. Lithium is 3. So lithium is coming with one more kid. एक room खोलना पड़ेगा आपको. So when the period becomes 2, the number of orbits occupied will also become 2.
Each period.
And it will continue to till neon. After that, sodium will come. Then you have to open the third wala room also. So let's see. Okay, good. So atomic number 3 is lithium. Number of electrons for lithium is how many? 3. Now how do we allocate 3? 2 maximum capacity occupied, and then 1. How many can it take? 8. But wait, is it not the valence shell? Yes. What is the rule? Valence shell cannot have more than 8, but it is only 1. Chalega. Are you understanding the rule? You have to obey both. Max count is how much? 8. We have filled only 1. Then every time you see that, khali isi ko mat dekho. You also see if it is the valence shell, then see in the valence shell how many can I put. So in fact, now all the elements that you will see, this will not open. This one will go on opening, because this can eat up to how much? 8 electrons. So if you would like to look at lithium, lithium looks like this. Lithium has got 3 protons. This is his first shell, which has 2 electrons. And then he has got another shell where there is 1 electron. This is K, this is L. This is how lithium is looking like. चाहे तो बना के रख सकते हो, आपका आइडिया क्लियर रहता है. लिथियम, ठीक है ना? अब एक चीज समझो. Look at me. After lithium, who is there? Beryllium. Beryllium will, when it comes to the hotel, also gets 2 rooms. First room for 2 of its electron, and second room has got 8-seater capacity. And beryllium comes with husband, wife, and 2 kids. So no problem. The 2 kids will be jumping around in that 8-seater room. Understood? Chalo. So let's fill up. Now next is beryllium, number 4. Beryllium. Beryllium's atomic number is 4, so it will have 2 here, 2 here. This is the electronic configuration of beryllium. Got it? Now you'll see some more interesting things. Okay. Ajao. Lithium, beryllium, and then same period we continue up to boron. Boron atomic number is how much? 5. Boron. Boron will be 2, and boron के 3 बच्चे. अभी 8 बेड है बाबू, देते रहो उनको. Boron. After boron, carbon. Carbon is 2, 4. After carbon, nitrogen, 2, 5. Then comes oxygen, 2, 6. Then fluorine. Then comes fluorine, number 9. Fluorine will have how many? 7. 2, 7. Now be ready. 2, 7. Fluorine is only 2, 7. That's 9. After fluorine comes neon. After fluorine comes neon. And neon is, why am I writing here every time? Number 10, neon. Neon के 8 बच्चे हैं and 8 beds were there. I think the hotel now has to open another room for the next people. Okay, hotel has to open another room for the next people. Clear? Okay, after neon हो गया. हाँ, sodium. So इसको क्या करेंगे? Let me see if I can do some jugglery here. I need to shrink this a bit. No, not the everything did not get selected. That is the wrong thing with this. Okay, we can't help it. Children, you have written till here, right? Okay, I'm following again from here. Okay, wait for me a little bit. This is atomic number. This is the element K, L, and M. Fine. So this is my atomic number. This is my element, and then I have K. I have K, L, M. Right? We are done up till 10. Okay. So let's start with a different color now. Green. So we are at 11. Why 11? Because we have started period 3. These were all in period 2, period 1. Now period 3 has started. So period 3 starts with 11. The name is sodium. Sodium has got 11. 2 here, 8 and 1. Open one more. 2, 8, 1. Okay. Acha. Now a very interesting thing. Why did you not make this one 9? Because the rule is L can maximum have only 8. ठीक है? चलें आगे. After sodium comes magnesium. Magnesium will have 2, 8, 2. Okay, magnesium हो गया. And then we will come 13 aluminium. Aluminium will be 2, 8, 3. After aluminium we have come to carbon. Carbon के नीचे है silicon. Silicon is 2, 8, 4. Okay, then comes nitrogen. Nitrogen के नीचे is phosphorus. So phosphorus, अरे यार, number 15. Phosphorus 2, 8, 5. After phosphorus, oxygen. That means we will have sulfur. Sulfur will be 2, 8, 6. Then 17. 17 is chlorine, so it will be chlorine. 2, 8, 7. Okay. After chlorine, we have number 18, who is argon. 2, 8, 8. Got it? Period 3 over. Period 4 starts. Period 4 starts, and I start with lavender. Okay. Period 4 is 19. Now this is interesting. 19 is potassium. Potassium. Now potassium, what is the maximum capacity of M? The maximum capacities were 2, 8, 18. These were the max. 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 Now potassium is how much? 19. 19 means, look here, look here. 2, 8, 9. कितना लेगा? 18. 18 beds are there, only 9 children. But remember the law, another one. Then this becomes the valence shell. Valence shell cannot have more than 8. So you have to open the next orbit, which is your n orbit has to get opened up. So we open our n. And n can have maximum how many electrons? You can have maximum 32. This is very dicey. Children generally don't understand this. I need to fill how many electrons? Tell me. 19 electrons. So let's fill 19 electrons. 2, 8. 10 electrons gone. How many more electrons to be accommodated? 9. Why do I not put 9 out here when the maximum capacity is 18? Have you got it? Why do I not put 9 here when the maximum capacity is 18? Not allowed. Because if I put 9 here, this becomes the last shell. So this gets a special category called valence shell. Valence shell can have maximum 8 electrons. So no matter you have capacity, you have to put the electron into the new room. Therefore, 2, 8, 8. Then this becomes 8 and 1 opens up here. Got it? That's why in some books it will be written for the first 20 elements, penultimate shell can have maximum of 8 electrons. This is called ultimate. This is penultimate. Got it? And after sodium, our last 120 is calcium. So it will be 2882. 2882. Understood? Yahan tak koi problem, anyone? Now you will see a lot of interesting happenings out here. I will not change the screen. I'm writing some general things out here. Valence shell or valence orbit. Children, from the board out here, can you identify the valence orbit for each element? For hydrogen, it is K. For helium, it is K. Lithium, it is L. It is L up to neon. And then the valence orbit becomes M. It starts from sodium up to argon, it is M. And then the valence orbit becomes N. It starts from, for us, potassium and calcium. Okay? Fine. You now know valence shell. There is a country called India. The people who reside in that country are known as? Very good. So you should know now what are valence electrons. Valence electrons are the electrons that are present in the valence shell of an atom. Likh lo chalo. Valence electrons. Very important. Valence electrons. These are the electrons that are present in the valence shell of an atom. Valence shell, the last shell. Valence electron, the electrons who are present in the last shell. Got it? Now, let us do one interesting observation out here. Okay, let us do some interesting observation out here. This is not periodic table. This is an electronic configuration chart. The periodic table is something which is this. This is the periodic table. Got it? And if you see the first period is what? Helinaki. For us, only Helinaki. So we say friendship, whatever it is, Helinaki. This thing we should know. Okay, let's go here. Now, in this electronic configuration chart, let us hunt the first period elements. What is the first period? Helinaki, Heli, then Na, and Ki. These are the first period. Can you just check their valence electron count? Just check.
1, 2, 1.
2 हो ही नहीं सकता है. I will chop off my ear if you see 2 electrons. I am asking what is the valence electron of these elements. Pay attention. 1. They belong to? How can you say first period here? You are not paying attention in the class. They belong to which group? They belong to which group? First group. What is their valence electron count? 1. Did you find something? Group 1 elements have valence electron 1 only. Group 2 will have 2, but don't go by that. Wait. Group 1, whether it is hydrogen, whether it is lithium, whether it is sodium, potassium, in the case of rubidium, what will happen? Another shell will be opened up, but only 1 electron. Here another shell will be opened up, only 1 electron. Here another shell will be opened up. So write down. Group 1 elements have got 1 valence electron. These will be very, very handy things which you are writing. Baad mein, these will become very interesting for you. Group 1 means 1 valence electron. So now if somebody tells you, what is the valence electron for lithium? You try to place lithium. Lithium is in group 1, so 1 valence electron. Samajh mein aaya? Group 1, 1 valence electron. Okay. Are you ready? Let's search group 2. Beta mange kar for you. Beryllium, magnesium, calcium. Beryllium. After that we will hunt for whom? Magnesium. Magnesium. And after that we will hunt for calcium. Just look at their valence electrons. 2, 2, 2. समझ में आ रहा है ऋषिका? The valence electron for this is 2. The valence electron for this is 2. The valence electron for this is also 2. They all belong to group 2. So group 2 elements will have valence electron as 2. But don't try to play that logic hereafter. We'll see how to play that logic hereafter. Let's see. Are we ready? Remember, children, we are only playing for whom? We are playing for only first 20. So our next is group 13. In 13, we have got boron and aluminium. You can keep seeing your periodic table. In 13, we have got boron and aluminium. What is their valence electron? 3, 3. But somehow our arithmetic is not telling now. Group number. So we see that for group 1 and group 2, valence, group 2, okay, valence electron for group 1, you have got 1, for group 2, you have got 2. However, when you came down to group 13, you are finding that the valence electron is 3. Match nahi ho raha hai. So let's match it. The matching is from 13 to 18. What did I say? 13 to 18. The valence electron count is a formula called group number minus 10. What is the group number? 13. 13 minus 10 is 3. Match karega abhi. Abhi match karega. So for group 1 and 2, the group number itself is the valence electron. But from group 13 to 18, it is group number minus 10. यहाँ से आइडेंटिफाई हो जाएगा अभी ऑटोमेटिक ये सब लॉजिक समझ गया आप पीरियोडिक हाउ डू यू थिंक आई एम मेकिंग पीरियोडिक टेबल सो क्विकली डू आई रिमेंबर इट नो शी इज रिमेंबर ट्राइंग टू रिमेंबर द राइम एंड द सॉन्ग उसकी जरूरत नहीं है द राइम एंड द सॉन्ग बचपन में अच्छा लगेगा बट नाउ यू विल अंडरस्टैंड द अरिथमेटिक ऑफ इट हाउ इट इज अरेंज्ड विल अगेन रिविजिट द पीरियोडिक टेबल एक बार फिर बनाएंगे जब तक ये क्लियर नहीं you're not good in chemistry. आगे चले. So now our job is to identify group number 13 we have identified. Shall we identify 14? So 14 will be whom? Carbon and silicon. Okay. So this is carbon with 4 and if you see silicon, silicon is also with 4. That means for group 14, the valence electron count is 14 minus 10 which is equal to 4 and it matches. It matches. Got it? Chaliye, let's go to group number 15. Group 15 has got nitrogen, which has got 5 electrons, and phosphorus, which has also got 5 electrons. So group 15, the valence electron count is 15 minus 10, which is equal to 5, and our two elements are exactly obeying it. Clear? पूरा तुम जब तुम स्कूल में पढ़ोगे ना atoms and molecules will be dancing in the class because you know everything now. Okay, got it? Okay. Then we come to group number 16. Group 16 has got oxygen, which is 6, and also has sulfur, which has got 6. So group 16, the valence electron count is 16 minus 10, which is equal to 6. Agreed? Now we come to group 17, which is fluorine, chlorine, bromine, iodine. Okay. So fluorine and chlorine, we have got 7 electrons and it exactly tallies. Group 17, valence electron should be 17 minus 10, which is equal to 7. And then we come to group 18. Group 18, now there is something interesting. Helium, group 18 means what should be the electronic valence electron? 18 minus 10, 8. What about helium? Helium has got 2. यहाँ पे थोड़ा सा there's a contradiction. Okay, but we'll see for the others. So if you see group number 18, in group 18 we have not yet ticked it. I'm just putting an asterisk out here because यहाँ पे कुछ लोचा है. The rest of the group 18s are the neons and the argons. If you see 8, you find an 8 here also. So group 18 is valence electron is 18 minus 10, which is equal to 8. Question arises, sir, how do you then satisfy it for helium? Now this rule gets applicable for the elements which have more than one shell. Helium is a fellow who has got only one shell called K shell. Just see, helium has got one shell. And in its K shell, it has got how many electrons? 2 electrons. Just keep that much in mind. The rest of its group members, neon, argon, krypton, xenon, they're having how many electrons? 8 electrons. Is it their valence shell? Yes. Is their valence shell completely filled? Let's check for his valence shell is K, but it is completely filled. And their valence shell is, in this case, we are finding the valence shell of argon as M, and we are finding the valence shell of neon as L. In both the case, it is completely filled. Valence shell can have maximum 8. Now you should not say, sir, where is it filled? It is 18. No, it's a valence shell. Valence shell can have maximum 8. So here there is one more criteria, right? Valence shell can have maximum 8 electrons. Valence shell can have maximum 8 electrons. And this is called an octet. What is it called? Octet. Yeah, octet rule आएगा अभी. This is called an octet. मैंने कहा था ना, हर चीज को सीखने का एक टाइम है. Valence shell can have maximum 8 electrons, and this is called an octet. However, right, however, if the valence shell is the first shell itself, bracket में लिखिए, that is K. However, if the valence shell is the first shell itself, which is K, if the valence shell is the first shell itself, that is K, it can have maximum of 2 electrons. It can have maximum of 2 electrons. And bracket में इस criteria को लिखिए duplet. This is called a duplet. So you have understood something more called the octet and the duplet rule. Octet rule tells you that if you are the valence shell, then you are completely filled with 8 electrons. If you are, and in octet you write, number of shells should be more than 1. Octet rule applies where total number of shells is more than 1. What did you write for octet? You wrote for octet that the valence shell can have maximum 8 electrons, and this is called an octet. Bracket में लिखिए, when the number of shells is greater than 1. When the number of shells is greater than 1. You see, anyone who is greater than 1, the maximum you occupied was 8. Anyone who is more than 1, the maximum you occupied was 8. 8 is the maximum, right? So let us revise whatever we have learned here. Electrons filled up according to the rule of 2n square. 2n square is the maximum number of electrons that can be accommodated by an energy level or an orbit. However, saying so, if that energy level on an orbit is the valence shell, then there is a exception that it can only hold up to 8 electrons if the number of shells is more than 1, and can hold only 2 electrons if the number of shells is 1. So the 2 electron criteria is known as duplet. The 8 electron criteria is known as an octet. Clear? Okay. So now you see. Now I'm going to make another color criteria here, and I'm going to look at my inert gases with this purple color. Let's look at the inert gases. This is an inert gas. Do you agree? This is an inert gas, right? And this is also an inert gas. Do you see some speciality? Inert gases have their valence shell completely filled. This fellow had only one valence shell and it is filled. This fellow's valence shell is filled. This fellow's valence shell is filled. So write that. Inert gases have their valence shells completely filled. Inert gases have their valence shells completely filled. And then you make a fang. You know, fang is something like this. See, 2 arrows open up after your statements. Inert gases have their valence shell completely filled, and you open up 2 arrows. Can I start with the arrows? On the top arrow you write helium, helium following duplet rule, helium following duplet rule, helium following duplet rule, and in bracket you write since only one shell, that is K, i.e. K, that is K. Helium following duplet rule since only one shell, which is the K shell. नीचे वालों में लिखिए the rest following octet rule. किसमें लिख रहे हो रैन? हीलियम फॉलोइंग क्या लिखे हो तुम? Duplet rule, as there is only one shell, that is bracket K, and on the other fang you write rest of the inert gases, and rest of the inert gases please write neon, Ne neon, comma Ar argon, comma Kr krypton, comma Xc xenon, comma Rn radon. Xc radon, Rn, sorry, Rn following the octet rule because they have more than one shells, है ना? अब ऐसे भी देखो, जो आपने याद लिखा कोई महान चीज नहीं. हीलियम बेटा कौन से पीरियड में है? यहां चलो, यहां पे चलो, 1 मिनट. हाँ, हीलियम कौन से पीरियड में है? हीलियम इज इन पीरियड 1, सो ऑब्वियसली इट हैज गॉट वन शेल ओनली. अब उसमें कितना मैक्सिमम इलेक्ट्रॉन आएगा? 2. Therefore it follows duplet rule. What's so big about it? Neon comes in period 2. So how many shells? 2 shells, K shell and L shell. L can have maximum of how much? 8. So neon follows octet rule. Come to argon. Argon is period 3. So argon is KLM. देखो argon में M भी fill up हो गया है. M has been filled up. So argon can have how many electrons? 8 electrons maximum, and that is filled up. Have you understood? So the next thing that we learned, itna तो clear हो गया. So next thing we learned is, as I told you, that the periodic table consists all atoms which are actually the photos of girls in Shadi.com portal. Not all girls like them are well behaved. So you should ask, sir, are there any well behaved girls? Yes. So in the case of well behaved, I will change the word of well behaved by something called stable atoms. Stable atoms. Atoms which can exist. सच्चाई यही है, इतना बड़ा शादी.com पोर्टल में अच्छे गुणवान गुणवती संस्कारी लड़कियां सारे नहीं हैं, कुछ ही हैं. तो सर उनका फोटो क्यों है? Periodic table में भी all are showing their beautiful faces. I'm oxygen, but I'm not like as you're thinking. So who are the Gunwans? The Gunwans are known as stable atoms. They will be helium, neon, argon, krypton, xenon and radon. And why they are stable? इन्हें हम stable क्यों कहते हैं? Because for them their valence shell is completely filled, and these follow octet, whereas this one will follow duplet. If I have one shell, I am fully filled on that. If I have more than one shell, then also I am fully filled. No other atom have their shells completely filled. If you have little bit of doubt, then you can just see the whole raita that you had spread. Show me one atom in these 20 where they are completely filled. They are not, except the ones that I have made in rectangle, because you are studying only first 20. In first 20 only these 3 come in: helium, neon, argon. All of them have completely filled. So you understand. Therefore, when you have some good boys or good girls in your housing colony, then your peer pressure increases a lot. Chemistry is the literature of science. Your peer pressure, and it has to be understood with examples. Your peer pressure increases. Why? Because every time you do something nonsense in your house, your parent says, can't you be like Rishika? Usko dekho. Usko dekho. हम बोलते हैं ना, उसको देखो. Can't you be like Rishika? Usko dekho. So, all other atoms are unstable, and you won't find them in the universe as atoms. Question arises, sir, do I not get an oxygen? You'll get an oxygen, but in combined state. Shall I get iron? Combined state. Some iron oxide, iron carbon. Iron तो नहीं मिलेगा, मिल ही नहीं सकता है, मिल ही नहीं सकता है. All of them are unstable. So all of them have something which is known as the race for stability. They have a race for stability. कीड़ा लगा है उनके अंदर. And the race for stability is simple, to have either duplet or octet if shell count is equal to 1, if shell count is greater than 1, then you that. So all other atoms will be now fighting for what? Stability. But stability is something abstract. We need to talk in terms of numbers. तुम्हें क्या पता? तुम जाके पूछोगे, ए ऑक्सीजन, are you stable? ऐसा थोड़ी है, ऐसा नहीं. Some numbers you have to assign. So that number is what? That number is duplet or an octet. That means they are hunting, or they will be hungry for either making an octet or a duplet. But question arises, bhai sahab, you were God gifted with so many electrons. In order to make octet or duplet, you need more electrons. Let's look at sodium. Sodium is 281. Sodium को 7 electron चाहिए. But you are not so lucky that you are born like that. That lucky fellow was neon or argon. Are you understanding? So they'll have a run. So they need either a duplet or other. That means there is a electron deficit. ये तो समझ में आ गया. There is an electron deficit. So in economics, as we say, scarce commodity. So when you have a scarce commodity, you can have two ways out here. Either you steal something, or you look for somebody who is ready to donate to you, right? This is scarce. So whenever things are scarce, then starts the exchange, barter. I have got cow, cow gives milk. She has got hen, hen gives eggs. I don't have eggs at home, she doesn't have milk at home. We both want each other's product. So barter has to happen. That means whenever there's an electron deficit, now in order to fulfill this, there can be only two ways. Either you have to look for donors, right? Somebody will donate you electrons. So if somebody is donating you electron, then an acceptor is automatically created. I give my entire trash to his house. I am a donor. Then he becomes what? Acceptor. If there is a donor, there has to be an acceptor. तुम मंदिर में दान करते हो तो पैसा कहाँ जा रहा है? या तो भगवान ले रहा है या पुजारी ले रहा है. Some acceptor should be there. So there will be created somebody called acceptors. Understood? Donors and acceptors. Right? This action between donors and acceptors can be in two different manners. Just imagine. I need crayons. This girl has got crayons. Mishka has got crayons. So one way of creating a donor and an acceptor is, which is the most easiest one, which is known as a transfer. Mishka gives her crayons to me. I give her some monetary benefit against it. From today, I have no right on the money. She has no right on the crayons. This is very simple, right? Mishka has got 6 crayons. I have got another 6 crayons, which are completely different colors. However, this girl does not have light green. I have light green. I want dark green. She has got dark green. So in that case, we can also be donors and acceptors by something which is known as sharing. Sharing. But इसमें लफड़ा है. Mishka says, sir, keep this box with you. This my crayons and your crayons are same. We will share from today. Very good. Then there is a friend of Mishka named Abhigya who keeps on saying, who has the ownership of your crayons? She says, no, we are sharing. नहीं, but किसके घर में रहता है? She's. So that relation does not stay wrong. Exactly in chemistry also this will happen. Let's share. Ownership किसके पास है? Let's share our bike. We have to park it at somebody's parking. Now, who's parking your parking? Why only his parking? Why not her parking? तो शेयरिंग में झगड़ा तो होएगा, and you will see this in chemistry. ठीक है? आज हम यहाँ पे रुकेंगे. So wait, before we stop, what did we understand? Out of the 114, few are blessed to be stable, which are known as the inert gases. Why are they stable? Stable is a very, very bhavachak sangya, abstract noun. You have to get me numbers. They are stable because they have either a duplet or an octet. Rest of them do not have it. But rest of them are continuously under the peer pressure to become like that. That means they should be either a duplet or an octet. In doing so, they realize that there is an electron deficit. Now that deficit has to be made up. That deficit can be made up if somebody is ready to donate. Once somebody donates, somebody accepts. And this donation and acceptance can be done in two-way relationship. One is by a transfer, one is by a sharing. Say I give 4 electrons and you have got 4 electrons. I said my 4 are your 4. Are you octet complete? Yes. Your 4 are my 4. Am I octet complete? Yes. Understood? So from here, our story goes into the next class. But these do not have any lessons. Please watch the video and come. वरना आप कोई तालमेल नहीं बना पाओगे. Because next class onwards, so much of periodic table drawing will not happen. But I will say helium. What is valence electron? Aluminium. What is the valence electron? Group number. So you have to say group 13. 13 means 13 minus 10, 3. So aluminium has got 3. And better you say boron has also got 3. ऐसे सीखा जाता है.